For years, my family has visited my grandparents on St. Simon's Island off the coast of Georgia. We've watched the coastline change before our eyes. Once expansive sandy beaches have shrunk and dunes have eroded due to rising sea levels. These changes reflect a growing crisis affecting coastal regions worldwide. With climate change accelerating, it's crucial to examine areas already experiencing its effects. St. Simon's Island, located on the Altamaha River Delta, is one such place. As global temperatures rise, ice melts, and sea levels increase. Coastal areas like St. Simon's are on the front lines, feeling the impacts before many inland regions. Rather than focusing on how people adapt, I'll explore how rising sea levels affect local ecosystems and wildlife. I'll also discuss possible strategies to mitigate these impacts and preserve the island's delicate balance. St. Simon's has a long history of human habitation. Ancient shell rings show that people lived here as early as the late Archaic period, 5,000 to 3,000 years ago. In the 19th century, the island's northern region, Cannons Point, was home to plantations that thrived on cotton and fruit crops. These plantations, managed by figures like John Cooper and James Hamilton, used enslaved labor. Crop rotation techniques resulted in high soil fertility, which still supports the island's maritime forests today. While the southern end of St. Simon's is heavily developed, the north remains largely marshland and woodland. Cannons Point is now a protected nature preserve, home to historical ruins, trails, and an untouched maritime forest. It is located within the Altamaha River Delta and is vital for conservation. It provides a critical habitat for migratory birds and supports the rare maritime forests found along the U.S. coast. St. Simon's Island has a humid climate with hot summers and mild winters. Temperatures range from 44 degrees Fahrenheit to 89 degrees Fahrenheit. One of the island's greatest threats is rising sea levels, driven by increased carbon dioxide emissions. Climate models project a global temperature rise of 5.9 degrees Fahrenheit or 3.3 degrees Celsius by 2100. This will accelerate glacial melting and raise sea levels even more. NOAA data already show Arctic temperatures exceeding historical norms by at least 6 degrees. This trend speeds up ice melt and worsens flooding risks. Research confirms that rising seas directly threaten St. Simon's. Changes in tidal patterns impact the Altamaha River Delta's marshes. Some studies predict the delta could be underwater by 2100. The SSI Risk Finder suggests a near certain chance of a flood exceeding 4 feet above the current high tide line by 2130. Without adaptation measures, up to 5% of global coastal and estuarine populations could face annual flooding by 2100. The urgency for preventive action is clear.
Well, I'm bringing in, just getting the boat ride. Wow, oh Lord, it is coming higher. Oh no, with a gun. So close to putting my house down. Please stay away. So close. Please stay away.
Rising sea levels endanger both wildlife and human communities. St. Simon's, as a coastal wetland, is particularly vulnerable. Habitat destruction threatens mangrove and maritime forests, which serve as living environments for bird species, as well as natural flood barriers. Without them, flooding risks in residential and commercial areas increase. Estuaries, home to tidal creeks and salt marshes, are especially at risk. The UGA Marine Institute has documented marsh displacement, which disrupts food webs. Salt marshes are vital nurseries for many plant and animal species. Drone imagery shows seaweed degradation, further highlighting the damage. Higher sea levels also worsen storm surges, increasing beach erosion. Once dunes erode, the loss becomes a cycle, making future erosion even more likely. Sea level rise affects key species like great blue herons, bald eagles, dolphins, and manatees. Great blue herons rely on coastal forests and wetlands for feeding and nesting. Flooded marshes make their habitat less suitable. Rising salinity and temperature changes can drive away non game fish, which make up 75% of their diet. This could lead to food shortages, starvation, and lower reproduction rates. Bald eagles face similar threats. Habitat loss from coastal wetland and forest erosion could reduce their nesting sites and disrupt food access. As sea levels rise, changes in temperature and salinity affect fish, like flounder. A decline in flounder could leave eagles without a key food source, leading to energy imbalances and lower breeding success. Dolphins are also impacted. Melting Arctic ice has increased saltwater intrusion into freshwater habitats, altering prey migration patterns. This forces dolphins to relocate in alignment with their food sources. New habitats may not have enough resources to support them. Warm waters linked to glacial melt have also been correlated with higher rates of stillborn dolphin calves. Food scarcity means dolphins must expend more energy hunting, weakening their immune systems and reproductive rates. Manatees, which depend on seagrass, face food shortages. Rising sea levels inundate seagrass beds, making food access harder. This leads to starvation, lower energy levels, and reduced reproduction. Forced migration to less suitable habitats exposes them to more competition and human related threats like boat strikes. Three main strategies can help: conservation, marsh elevation, and dune strengthening. These efforts aim to protect habitats, ensure food availability, and maintain stable breeding environments. The St. Simons Land Trust protects Cannons Point Preserve, a critical habitat for shorebirds. Expanding conservation efforts, such as installing water barriers, could prevent habitat loss and maintain nesting sites for bald eagles and great blue herons. Regular ecological assessments would help monitor population health and ensure stability. Adding sediment to marshes can prevent saltwater intrusion and inundation. Elevation restoration efforts could sustain seagrass populations, ensuring manatees retain their primary food source. If pilot studies prove successful, this strategy should be widely implemented along the Georgia coast. Preserving seagrass beds prevents starvation in manatees and supports their reproductive success. It also maintains fish populations on which dolphins rely, reducing their need to expend extra energy searching for food. Reinforcing sand dunes helps defend against storm surges and high tides. Methods like dune grass planting, thatching, and hybrid dike core dunes can reduce beach erosion. This protects estuarine water levels and salinity levels, keeping dolphin prey species abundant and ensuring secure nesting sites for birds. Stable water and salinity levels also ensure food security for other coastal wildlife. Rising sea levels pose a serious threat to St. Simon's Island. The island's ecosystems, wildlife, and human communities are all at risk. However, targeted mitigation strategies can help prevent the worst outcomes. Conservation efforts protect nesting sites and food sources. Marsh elevation preserves essential plant and fish populations. Dune strengthening defends against erosion and habitat loss. These combined efforts reduce starvation, improve energy balance, and promote reproductive success. Maintaining St. Simon's Island's rich ecological landscape requires commitment and collaboration. The time to act is now to ensure future generations inherit a thriving coastal environment.